Birds flap their wings during flight. Planes do not. Planes are made from rigid metal or composite components. They're stiff and strong. And I don't want bits bending around during flight, thanks very much. But this plane, about to be launched over the safe and roomy, dried-up lake beds at NASA's Armstrong Flight Research Center, is designed to do just that. And it could lead to more fuel-efficient, quieter, and even supersonic passenger planes in the future.
16, 25, 30.
The project's called Spanwise Adaptive Wing, or SAW, and it uses a shape memory alloy in this scaled-down prototype. These special metals are triggered to change shape when heated or cooled. Instead of bulky hydraulics, this plane has a tube with the alloy inside, which twists and moves sections of the wing. That means it can be built right into the wingtips where heavy hydraulics would cause too much strain. You can see it in operation sped up here. The idea has been around for decades. In the 1960s, NASA developed the XB-70, where the outer wing panels were hinged to increase lift for takeoff, but then reduce drag for supersonic flight. Its actuators were big and heavy though. NASA Armstrong is also developing a project with the snappy title Adaptive Compliant Trailing Edge, where they've replaced the flaps on the back of a wing with a smooth surface which can be deformed. That promises the same advantages of quieter, more efficient flight, as air doesn't get buffeted around the extended flaps and the gaps that they leave.
Good. Both sides.
For the latest SAW test, researchers flew the plane in an elongated racetrack pattern, and engineers heated and cooled the alloys, folding the wings between 0 and 70 degrees. The next step is to scale up the technology and fit it into the wing of an F-18 fighter jet. And eventually it could be fitted to passenger planes, so the wings can adapt in flight to decrease drag. It may even allow aircraft with huge wingspans to fold up into small airport gates. Perhaps there is something to be said for flexibility after all.